I was given the chance to go to Tormach headquarters and to go play with their new 1500. I have a couple videos on this whole trip, but in this video specifically, Norman, who's a friend of mine who works at Tormach, we go through and look at every single detail of the 1500. Part of the deal with me going up there is that we would show everything, and we did show everything on this machine. Ball screws to the linear rails, the casting, the electrical cabinet, the coolant systems, chip management. We go through all of it, the good, the bad, the ugly. Tormach has no editorial control over this video, and they did not ask me to hide any details of the machine. I did edit this video slightly just to make it interesting and watchable, but I did not edit anything out that they showed me on the machine.
Should we transition to the nerdy dig into the machine?
Yeah, once
side?
I get most of the chips out, I'm going to start tearing it apart.
Well, let's start by talking about that. All right, Norman, tell us about coolant and chip handling on this machine.
So, on the 1500, have a few coolant options. I'm going to stop that right there. So we've got our standard flood coolant system. We've got a ring of nozzles around the spindle, fairly similar to what we have on the 1100s and 770s.
And this is better than what you have on the 1100s.
Yeah, so this gives you more degrees of coverage. We currently have 4 nozzles on there. We'll revise the design a little bit and have 5 or 6 for even better coverage.
What power is the pump?
So it's a 1/4 horsepower pump. For
really? It's only a quarter?
Yeah. 3/4 inch lines on the pump. Line restriction is actually the major reason for the increase in performance of the flood coolant system. But 1/4 horsepower pump for your standard washdown system, or standard flood coolant system. We also have a washdown system with 2 bars on each side.
So there's the washdown.
Yep, so 1 bar on each side of the machine. Those are powered by a separate 1/2 horsepower pump.
Oh, that's more power, huh?
Yeah, we just need more volume.
There's a lot more nozzles.
Yep. Yeah, a lot more nozzles. We're just trying to move more coolant. And those just flush all the coolant down to our troughs. And then out
Let's follow it.
Yep, out to the back of the machine. Where as standard, we've got 2 baskets for holding your chips. Or later, we'll have an option for a chip conveyor system that would go in the basket's place. On each pump, we have a filter as well, just to make sure we don't get coolant clogging all of our nozzles. And then we have a mist coolant system here, made by a company called Unist. That's an oil-based system, but still blows air, similar to our fog buster that we had previously. And we don't have it on this machine, but we also have an option for a through-spindle coolant system, which, as the name implies, your coolant would come straight through your spindle. That would be a separate pump sitting to the side of the machine, and we have another filter and pickup for that going to the...
Can we go see a different machine that has the chip conveyor and everything in the TSC?
Yeah, can.
All right, I'm gonna stop it.
So this is our through-spindle coolant system here, sits under the side of the machine. This is a prototype unit, so the production unit will be able to go a little bit more under the machine, so it's not taking up much more floor space. And then this is our prototype chip conveyor as well. You can see inside that we took our baskets out and it's just picking up coolant and chips from our troughs. We'll have a barrel under here as well. For our flood coolant system, we can show the pump a little bit. Fairly dark in there. But this is a 400 PSI system. We've got just our standard electric motor, and then it's a gear pump on there. A couple pressure sensors as well to make sure that we do have pressure when we command it on, but also that we're not spiking the pressure from deadheading the pump. But if we do deadhead the pump, we have a bypass line, this guy right here, where any excess pressure over whatever we have the set point at will just be dumped back to the tank, so it's not going to blow up the system.
400 PSI.
400 PSI.
Do you know what pressure the normal coolant system is?
35-ish. I'm not positive on that. But in a little bit, once Jakob's finishing, we can show the flood coolant action, or the through spindle coolant turning on.
Cool. We'll come back to that.
Yep.
All right, so we went through coolant. Now we're going to look at motion systems.
Yep, I'm going to take a couple of the covers off, and then we'll show the linear rails and ball screws and just the layout.
So to start with, real accordion cover or real way covers, not the little accordion things.
Yeah, so stainless steel way covers on every axis. The table is covering up the x-axis, but on the y-axis we have just a folding system on the front. On the back side is just one solid sheet that's bolted to the saddle, and that'll just travel through the column, just like any standard VMC, essentially. The Z-axis is an armored bellows system. You can see the fabric under here. So these are just all linked together, and then they'll just ride up and down with the Z-axis as we go up. And then on top, our headstock cover is just outside of the enclosure, so it'll protect the motor and spindle.
Do you ever need to clean those? Or does the Washdown take care of it?
The Washdown will take care of it depending on how much material removal you're doing. We took off quite a bit of material earlier today. So there were some chips packed up right on the front here, but most of that's just getting washed down by the coolant. So just like at the end of the day or every few hours or so, just spray it down with the Washdown gun and you'll be good to go.
And I don't think we said earlier, but there is a dedicated Washdown for the y-axis.
Yeah, so
not bellows. I keep wanting to call them bellows in the back. The way covers in the back.
Little hard to see, but we've got a sprayer nozzle right here.
Yeah.
That anytime you have flood coolant on, that's just going to be washing down the backside of the y-axis bellows. Just make sure nothing
super nice
packs up
feature.
there. Yep. Yeah, that's just standard with the flood coolant system. So we'll take the covers off next then.
Okay.
Unless there's anything else you wanted to get to first.
Nope.
Okay. I had a specific note in my list of feature requests of no Phillips.
It's a good call. So that's just like a kind of protective decorative skirt on the front?
Yep, so this is just to overlap the y-axis cover. Otherwise, we would have the joint where the cover actually bolts to the saddle, and coolant could get in there, coolant or chips. So,
makes sense.
A couple screws to take this guy off.
So you guys designed this machine, right?
Yep.
Like ground up?
Yep, every single little screw. There's just, most of it took, well, the details are what took most of the time. For example, the sheet metal for the headstock, this is revision 9, I think.
Wow.
You might have seen on the first prototype that like this power drawbar button was on the left side. We moved that over here. There's a separate panel right behind this one that is bolting to the headstock casting. This angle was changed. We changed the dimensions on some of those, like how far forward that angle was. So yeah, just going through a lot of tiny little details to make sure that everything works as it should.
Which is good because you guys have PathPilot, which is, I think, the best controller. I've never used one of the Datron ones, and people like those, but PathPilot is good.
I mean, it's kind of in the same vein of Heidenheim. Like, you've got your guys that really, really love it, and then guys that just... There's a lot of extra stuff built in that a fair number of people don't feel they need. So it just depends.
Okay, so we can see trucks and lube lines.
Yep.
I want to look at lube too. So that was that little protective bonnet thing that went here, which protected all this stuff. And now we can get the y-axis away covers off.
Right. Maintenance was a thing that we kept fairly well in mind as well, especially for my suggestions for the machine. You notice the manifolds, they're all right here at the front versus buried inside the middle of the saddle where it'd just be a nightmare to get to. On the back side of the headstock sheet metal, there's an access panel to get to the Z-axis motor if you ever have to do anything with it or the ball screw. We'll be able to see in a little bit too, the ball screw nuts are actually facing towards the motors.
Okay.
Or sorry, away from the motors. in case you ever have to replace a ball screw. We don't want the alignment of the motor to be changed. So we made that change to the ball screws so that you would be able to remove the entire ball screw without having to do anything with that motor mount.
Is this still belt driven?
The spindle?
Yeah.
Yes.
Okay.
Belt driven.
Is there a high and a low range?
No, single range on it. That button in Pathpilot is completely gone. So
Okay.
you don't ever have to worry about that. Between the motor and the spindle cartridge is also a timing belt versus a V-style belt that we've had on our previous machine. Cool. So I've got the front weight cover pulled back again. So now you can see our linear rails and our ball screw.
Do you know what size rails these are?
I am not 100% positive, but I believe they're 25 millimeter. The ball screws I know are 20 millimeter. For X and Y, they're 10 millimeter pitch. Z is 5 millimeter pitch. We just needed the additional torque for holding up against gravity. That's why on X and Y our rapids are 1,200 inches a minute versus on Z they're 600. It's just the difference in the pitch of the ball screw. So let me move this back a little bit more.
How about homing?
So on the 1500, if I e-stop our machine, right here where we've got our green LEDs, this is where normally we'd be seeing reference X, Y, Z, just like we would for A. But on the 1500, we have absolute encoders installed on the motor, so we don't ever have to reference the machine. That battery will just...
The mic will still hear you.
Okay. The battery will just keep position even if you e-stop or power off the machine. That battery will last for approximately 5 years. It is a little bit variable depending on how long you leave the machine off, where it would be consuming battery power.
So it's better to leave the machine on?
Generally, yes. But the major thing is actually if you move the machine while it's powered off. That will rapidly deplete the battery, so avoid doing that. But you could just leave the machine off, for a couple months. It won't be an issue at all. We have a battery on the A-axis as well. In this case, we've never referenced it. So once we do that, as long as you leave the A-axis plugged in, you wouldn't have to reference it again. But if you ever do pull it off, then you do have to re-reference the A-axis. And we can see on here, we have a 0 mark on the faceplate that rotates, and then just a engraved line in the housing of the A-axis. So all you have to do to re-reference your A-axis is hit reference. Oh, and I have my door open right now, so it's not able to reference. You'll get a pop-up saying align those 2 marks. You press OK. And then we're going to rotate and find the nearest index pulse of the encoder and back it up. So you only need to be within about 5 degrees by manually aligning it. Everything else is just handled by the homing routine. And then that'll hold it until we re-reference them, pull off the A-axis. Otherwise, it'll still be referenced. So
it's going to be a pain to see inside the head, isn't it? That's probably not worth it.
Yeah, because
that's not worth it.
There. All right, I'm going to drop the Z-axis cover still up. Before we do that, though,
what are you most excited for this machine as a tech? Like what feature does nobody else care about, but like you get excited about?
It's fairly hard to pick one, actually. If I had to say one, I'd probably say EtherCAT.
Okay. Which we'll get to.
Yeah, we'll get there. But outside of that, my experience has primarily been on robo-drills and Nakamura's. So robo-drills especially, other than size, it's the exact same components. We don't have a fully supported table, so there's one less iron casting for the saddle. But other than that, linear rails, ball screw, field bus servo motor on there, standard weight covers. So we're not missing anything, is how I feel. This, to me, is a huge step up. But to me, the 1500 is step one. Everything we do after this is going to build on it, but this is just such a huge step for us. The one thing I would say I wish we did more on the 1500 is I always want more spindle power.
Yeah.
Spindle power is an evolution rather than a revolution, like everything else on the machine is. But yeah, like the next 4 or 5 years, once we start getting everybody in the main swing of using these machines, will just be really exciting. There's a lot of little features that we put in the machine as well that I feel like being able to have the input in those just made the machine better overall. We don't have them installed on this machine because it's one of our prototypes, but on every machine we have 2 airlines run to the table. We have those airlines running through the cable chains all the way up there, and they're just plugged so you can use them for whatever. If you have some automation system or something you want to plug in. But otherwise you'd have your lines dangling through the machine, and they can just get in the way of everything. So just having those available is great. On the homing side, I didn't mention it earlier, but if your batteries ever do die on your machine, you don't have to worry about running out and getting a set of D batteries or whatever to replace them, or having an alarm that means your machine is down, over the weekend. I can just hit our LED and it's telling me it's already referenced, but if I want to, I can just re-reference the machine. And if I do that, after I shut the door,
Does it work with the way covers all?
it'll still work.
Okay.
But I'm going to do X instead of Y anyway. Re-reference.
Same thing as an 1100 where it finds the end of travel and then looks for an index pulse. Okay.
Yep. Yeah, so we're running into the bumper end of the end of the travel. We notice that torque spike from the load on the motor, and then we'll back up to the index pulse of the encoder. So you can remove the batteries off of every single drive and still do hard stop homing. And until you power off the machine, not even e-stop, it's going to retain the reference. So you can just run that. And that was a feature that actually came later in the development. So our prototypes ran that way for 6 months, and it works perfectly fine. So. I'm going to take our Z-axis cover off as well.
So we're opening the Z-axis way cover now.
Yep.
Now we just need a air knife or something so we can film easier inside the machine.
You could add one.
That's true. I could put one on the table with the camera, with one of your in-tape. Hey, look at that.
You could. Of course.
I thought you were missing fasteners here because it was a prototype machine or a showroom machine or something. No, these are pinholes.
Yep.
That makes sense. So that way, if you have an 8-foot bar of material sticking out the side, you can just put it up a couple levels.
Yeah. So this level.
That's
if you
for
get
whoever.
down, you've got about an inch to the top of the table for this one, and then you gain a foot for each additional step.
That's for whoever makes it into a who adds a bar feeder to the six axis, the micro arc.
Yeah. You could try doing that.
He said it had like a 30 millimeter through hole on that micro arc, which means you can now load 1 inch round, which is good because 1 inch round is, you can get a lot out of it and it's cheap and easy to find in a lot of materials. And there goes the screws.
Yep. Lost the screw.
Is the spacing between the rails the same on all the axes?
That I am actually not sure of. I'd have to ask engineering on that. I'm not sure where my screw went. So, exact same setup here. Just our ball screw and then our linear rails. They are all the same size linear rails for each of our axes. One thing that is different about the ball screw configuration that I didn't mention is that on all of our previous machines, they had a fixed free configuration. So we had our 2 angular contact bearings on one side, and then the other side of the ball screw was just hanging.
Floating,
Yeah, so that doesn't affect performance, but that does limit the maximum speed that you can run that ball screw at, because the end of it will start whipping. That does depend on how much length is actually free. The closer you get to the end of that, theoretically you could move faster, but practically speaking, your limit is the farthest unsupported length. So on 1500, we changed that to a fixed simple configuration, where on the far end of the ball screw, you can see for the y-axis here, and the same for the z-axis, and it's also the same for the x-axis under the table. This is just a regular rolling bearing, so you don't have axial support for length, but you are controlling to make sure that that ball screw doesn't whip. So you can run it faster. That's part of the reason we're able to go up to 1200 inches a minute. That's fun. I mentioned earlier the ball nut. So if you look up on the bottom there, you can see the flange.
And I see a lube line going to it.
Yep, we have lubrication lines going to all of our ball nuts, as well as to all of our linear bearing blocks. So in this case, this is the flange for the z-axis ball screw. So this ball screw has to come out down rather than going up the top, like I mentioned earlier. So we don't have to do anything with the motor mount and change the alignment of the ball screw after we replace it. So you can just drop this ball screw, loosen the coupling on the motor, and then take the entire ball screw out to the bottom. That's cool. For the z-axis specifically, there's a channel in the epoxy granite frame that gives you enough length, once you also take off the y-axis cover, to just take the ball screw out, throw a new one in, and then you're up and running again.
What's that? Oh, sorry. I'm distracted. What's that hole? What does that go to?
This hole?
Yeah.
This is just for cable passage. Currently not being used for anything, but there are some plans.
Future expansion.
Yeah. Yep. So you can see for our linear rails, right behind it, we've got our pusher screws pushing each of them up against a reference edge. And then they're bolted onto a replicated surface on the casting. So those are our precision surfaces that we use for mating everything and ensuring that we're straight and square. And then we have the rest of the casting. Outside of where the rails and bolt and ball screws bolt is honestly just support material, but it does a great job of dampening vibration, which helps on your surface finish.
Is there still a machine that doesn't have an enclosure on it where we can look more at the casting?
We don't have any without an enclosure here.
There wasn't one in the other room?
Going over to the warehouse.
Oh, never mind. I forgot about that one.
Let's go look it out.
Yeah.
This is an 1100 with an auto
Being
door.
sighted this week mostly.
What happens if you turn on through Spindle Coolant on a tool that doesn't do it?
There's already a video on YouTube of that. So that bypass that I mentioned,
Okay.
you're going to deadhead the entire coolant flow through the spindle. So that's going to build pressure in the line, but that's going to come back to the bypass,
Okay.
and that's just going to dump back to the tank. So the system will maintain 400 PSI, even though it doesn't have anywhere to go.
You're just wasting energy at that point and stirring coolant.
Yep. So I'm just going to show it first with no tool in there. So we've got a button on the UI that I can use. And
That makes for great video. I'm glad you closed the door though.
I have seen it without the door closed. Not quite as fun as you would think.
We've all done that.
Yeah. But if you're ready, I'll do it again.
Okay.
It is effectively instant for it to come on. So I think, which tool is that? Tool 9, I believe.
That is slightly terrifying.
A little wobbly, yeah. The Centro is worse and heavier.
You need like a 3D printed cone to go down in there.
Yeah, you could.
What is this?
That is a ring gauge. That's used for calibration of the spindle probe.
That makes sense. Does it have a size on it?
Yes, they'll have a size
and
on it.
Down to the, is that a millionth?
Nope, tenth.
Oh, it goes past tenths. It goes down to the tens of millions.
Okay. So we do have our button in the UI for through Spindle Coolant, but it is also M-code activated. Yes, I forget what our M-code is for through Spindle.
There we go.
There we go. Yeah, M207
Dude.
for through Spindle Coolant. You just have it in a program or built into your post.
Man, end mills are going to be so much more expensive on this.
If you get through Spindle Coolant end mills, this one's from Helical, I believe. But you don't have to have it through Spindle Coolant end mill. You could just run it through a standard call it. Yep. So the downside of through Spindle Coolant is you always get some dripping too. So it'll just keep running for a few seconds as it drains the lines.
That's fine.
And as a demonstration, I should just put that back in the ATC. Yep, store that tool. So this is just our master tool.
Calibration tool?
Yep, for calibrating our ETS. Obviously it's just blind on the end, so no hole through it.
So you're about to try to run coolant through the calibration tool?
Yep. Don't tell my boss.
Or the metrology nerds.
Oh, that's running right now.
Nothing exploded.
Yep, and you can't even see it, but our pump's running, and we're going back through that bypass valve back there.
Can we run the chip conveyor?
Yes.
Turn this
I'm going
off
to take
first.
this out first, so turn that off.
Oh, in the washdown.
Yep. So you get a little spurt of coolant.
Because you just pressurize that to 400.
Yes. But it's not going to hurt the machine or you. Just get you a little bit wet. And then washdown. We've got our 2 bars on the side. Another button on the UI here. That'll turn it on or off manually. And in a program that'll just turn on with M208 or turn off with M9 and 209.
So how would you normally have this in a program? Would you just turn it on and off once every couple minutes, or would you leave it on all the time?
So you generally would probably just leave this on all the time. You can run it intermittently if you want, but there's no downside to having more coolant washing down in the chips. You can let it build up a little bit and then try to wash down the chips if they're really light or really heavy. That might help it wash down, but just depends on the situation. So, for our chip conveyor, we've got manual controls here. Oh, cool. We're going forwards. Or if you have a jam for whatever reason, you have a secondary button for reverse. And then small potentiometer for speed control.
Cool.
Yep. So the speed control is only set on the control box here. And then you do have your manual buttons, but we also have an on-off command that can come from the machine. We do have another UI button that's currently not implemented, but I can remember our M code, which I believe with M232, 31, our conveyor turn on.
I hear sounds. Yep, it's going forwards.
Yep. So if we use M231, that'll just continuously turn the conveyor on. You can add P and Q arguments to the M code. That'll set time on and time off if you want to run the conveyor intermittently. That way you can let coolant drain from the chips that are built up on the incline, run it for a little while, refill the incline with chips, let those drain, and so on and so on.
Is any of that set up in the post, or do you have to use a pass-through NC?
So that will be built into the post. The problem is being able to select the different timers if you want. So that'll probably just be manual added if you want, or running the M code. That'll be built into the post as an optional selection.
And this thing, is this available yet?
No, the chip conveyor and through spindle coolant aren't currently available as of summer of 2024. Those will be available fall of 2024, but we don't have a specific date for release yet.
Is there any installation process?
Yep. So these are add-ons to the machine. Even if you get a factory assembled machine, these will still have to be installed as well. But for through Spindle Coolant, you obviously have the main unit here that sits next to the machine. You do have to run the coolant line up through the cable chain to the spindle. So that'll just be running the hose essentially. And then you're installing the rotary union onto the spindle. That's it for installation of the TSC essentially. There's no electronics you have to wire or anything, just hook up power to the TSC unit, connect your control cables, install the rotary union and the hose. For the chip conveyor, it's essentially the same story. You do have to remove the baskets from the coolant tank. In that process, you might want to drain the tank, but it's not absolutely required. But then you're going to have to put the chip conveyor into the tank, which will require a forklift to do. You don't want to do it by hand, that can be fairly dangerous. But then your control cable to the machine, that'll just plug into a port on it, and then you're able to run. Just supply power to it.
Could you do that with like an engine hoist? Or do you actually need a forklift?
Never been tested.
Okay. Don't try this at home, kids.
I have doubts of being able to do it easily because of the feet sticking forward. Those are probably going to run into the coolant tank. So this is our unit system. So this is for mist coolant. We have our air supply running through it. This is unlubricated air, so we have it before our FRL. And then this is our container of actual oil. So we'll mix the air, the oil into the air, and then this goes out to our nozzle. With the unit system, you have a pneumatic flow control built into the unit, so you can precisely control not only how much air you're sending through the system, but also how much oil. So you can control that ratio very, very well. You have a control knob on the side here, and two more additional knobs here. So you can control not only how much oil is being sent with each pulse of air, but how frequently those pulses are.
Oh, so it's a pulse kind of?
Yes.
Oh,
yeah,
cool.
It's a pneumatic pulse generator, essentially. So you can set it, if you want to, that you have a lot of oil going in very few pulses, or a little bit of oil going in a lot of pulses.
Is the oil pulsed or is the air pulsed coming out of the nozzle?
Both.
Okay.
Yep.
And how high of a pressure can you set it to?
Unist recommends around 40 or 50 psi.
Okay.
But if you go above that, it's not going to hurt the system. You are going to consume a significant amount of air if you go above that, though. Yeah.
But the old, what was the Mistbuster? Those maxed out at like 30.
Yeah, those had a limit of 30 psi, and you weren't able to really control how much fluid you're sending in.
No.
You just pressurized the container, and you got what you got based on the knob.
All right. So now let's look at the casting.
Do you want to go to the other machine?
So we should have a naked one we can look at. Yeah.
Yep.
This is a giant cube of robots. Robots, robots, robots.
So this is the main casting for the machine. So it's a one-piece design. Once it's completely assembled, we have two separate castings. We have our base here, and then our column. And we cover up the seam fairly well, but right about here is where the actual split is. We epoxy those two castings together to make them a single unit. But you can see that this is just a solid block of epoxy granite. So it does an extremely good job of dampening vibrations. And then we have a 3-point leveling system on the machine. So it's not even required that you level the machine, you can just drop it on the floor. That goes all the way down to the base. You can see that we've got steel plates that are epoxied into the casting as well, that we have our feet bolted into. Very simple design. We have threaded inserts for various panels, our tool changer, the enclosure to mount to, our electrical cabinet as well, and then all of our hoses and cables. Y-axis cover goes underneath the column right there.
Are these threaded inserts, do they cast those in place, or do they cast it, drill them out, and then like epoxy them in?
They're cast in place. So we have a steel mold that's just a negative image, and the mold will have a through hole that they're just able to pass a bolt through. So they'll thread the insert on inside the casting, just hold it in place with the bolt, pour all the epoxy granite in, then they'll remove the bolt and then disassemble the mold to bring the machine out. And then after that, we'll do all the finishing and painting.
Do they like put it in a giant vacuum chamber to get out bubbles or shake it or anything?
That I'm not sure of. I know that the top surface that you get that's not covered up by the mold, that will have a rougher finish, which in this case is the backside here and the bottom of the casting. Those I believe that they do like with a blowtorch over to pop some of the air bubbles that come up.
Yep.
But I don't know if they do any specific vibration or anything. I would imagine so, because compaction is one of the major issues with the casting. You want to make sure that you have a very evenly distributed mix of epoxy in your aggregate.
And look how thick that is. That's what, 6 inches, 8 inches thick there?
Between these two holes, this is 14 inches-ish.
Oh, it looks like it stops, but it's drafted in both directions.
Yes.
Okay, so that's all solid. There's no hollow in there, except for a couple electrical passages and
We
stuff.
actually were considering whether we wanted to put a cavity in here. That idea was very quickly squashed by customs, because they would destroy the machine to make sure that there was nothing inside of it. Yep.
So you're not shipping drugs in your 1500?
It's been done in machines before.
Huh.
But yeah, this casting, a lot of the design considerations were put in place as far as weight and height specifically. The base machine without the enclosure or any add-ons is 2,800 pounds. That's because the limit for liftgate delivery is 3,000 pounds. So we needed to make sure we were right under there to make sure guys can get machines in the garage. The entire machine is underneath an 8-foot ceiling without the mist collector on it, to make sure it can fit in most garages. So those were definitely in mind as we were designing the machine.
Do you have a pallet jack? Can we see how a pallet jack fits under it? I don't want to lift it. Let's not lift it, but... All right, we're recording again.
All right.
All right, we're not actually going to lift it, but I just wanted to see how the pallet jack fit.
Yep. So
right from behind.
With a standard width pallet jack, it can fit. It is very, very close though. On these spacers, it's basically a horseshoe shape. So there's a cutout on the side of them in order to get them around our rod. You have to have that flat of the cutout oriented in on both sides. And I don't believe that was done on one of these sides. This one it is. Yeah, that one's off a little bit. So very, very close, but as long as you orient those properly, you can get a standard size pallet jack in there. Alternatively, use a
narrow pallet jack.
Yep. This will fit without a problem.
I like how it's designed so that the heavy column of the machine is right at the back of the pallet jack.
Yep.
That is nice.
You can lift with the pallet jack at the front of the machine as well. You do need to make sure that you are fully inserted with the pallet jack, and also you want to take off this kick plate for your regulator in order to let you get a little bit deeper. The jack of the pallet jack will hit right on there. But yeah, you can move the machine from the front side as well if you want to put it up against the wall and then lift away. So these plates that our feet are bolted into, they extend about 5 inches into the casting. So both in front and back. That's actually what we're lifting on the pallet jack.
Can you pallet jack it from the side at all, or only front and back?
You really don't want to try moving it from the side. If you have a forklift, you could set your forks facing so that you're still on those steel plates.
Okay.
But you do not want to be lifting on the actual epoxy granite itself.
Do you need fork extenders?
You'll probably need fork extenders as well. If you have six foot forks, you shouldn't need them. But if you have 4 foot forks, then you'll need extenders, yes.
Does this one have the in-table air?
Yes, every single machine has 2 air lanes.
Okay.
Running to the end of the table.
And those are normally open, right? Or well, they're not even normally open. They're just always open because there's no switch.
Yeah,
or
there's no
solenoid.
solenoid. They're just plumbed straight into the manifold. So as long as the machine is pressurized, those are pressurized.
But you could theoretically put a solenoid on the back,
Yep.
or if you had like a valve, you could put it on the table.
Yeah.
For like a chuck puck or a Pearson system.
So those 2 lines run to this splitter right here. So if you wanted to, you can just take this off, cap this port, and then run these lines to whatever you want. A solenoid, some kind of manual valve, have it robot controlled, whatever you want.
Is there any other air system things we should talk about?
Nope, that's it for pneumatics.
Well, there's the air gun in the front, which has
I
its
did
own
not mention
regulator, which is nice.
yes.
So there's, I'm not sure if this one has one, but air gun hose with air gun there, and it has its own regulator. Mm-hmm. And it looks like you can go lefty if you want to.
Yes. Very, very important. Most important feature on the machine.
Is it hard pipe to that, or?
Yep. So that manifold we were just looking at, one of those lines comes right up here underneath the enclosure. So that's just always running. We didn't look earlier. Scratch that. It's not on this machine. But for the flood coolant system, if you have it installed, your washdown gun is mounted right up here. Additionally, if you have a probe installed, the receiver is sitting right behind your controller here. So we have our cable running up above and then back to the controller.
Ooh, it's an Allen key to open, not a coin.
Yes. So we have our main electrical cabinet here. We have a secondary electrical cabinet for the ATC if you have that installed. That just contains a breakout board and the ATC servo drive. Otherwise, fairly simple layout. On top, we have all of our servo drives, Spindle, XYZ, and A, if installed. Underneath, we have EMI filter, 24-volt power supply, and then an I/O breakout board. A couple circuit breakers, terminal strips, and contactor for our Spindle drive. But compared to our previous machines, fairly simple layout. Everything in here is either 220-volt AC or 24-volt DC, so standard industrial voltages. Each of these drives is connected to our EtherCAT chain, so we have just regular Ethernet cables, daisy chained from each drive, as well as a bulkhead connector right here that'll go out to our ATC electrical cabinet. So each drive also has I/O built into it, has several digital inputs and outputs. Those we run to our I/O breakout board, and those control any of our sensors, our switches, our door lock, coolant pumps, any device we need to turn on or off. We have that I/O built into the drives, so we make use of it for everything we need to control versus having separate I/O modules that just add cost and space to the cabinet.
So there's no Mesa board or anything to
Nope.
the interfaces between the computer and the control.
Yep, this Ethernet cable runs straight to our control. No control board whatsoever. It's just all on the EtherCAT bus.
That's really cool.
Yep.
So from factory, without any add-ons, what unused I/O does it have that you could use for automation or whatever?
So everything is already pre-assigned. We do have one input and one output assigned to be accessory input and accessory output. So those can be used for whatever you want. We also still have our USB I/O module that can be used for general purpose with M64, M65.
What are these? So these are, okay, accessory 1 and 2.
Yep, so these are the accessory inputs that I mentioned. One of those is actually used for the through spindle coolant system for our pressure sensor.
It's not this one?
You're correct, actually. So these are our accessory
sign.
inputs. Yeah, and then we have TSC that connects here as well. So these two are our inputs. We have additional connectors a little bit hidden on the bottom of the machine. Those are our TSC and accessory outputs, as well as our probe connector. This cable is from our probe receiver, so just one cable runs straight to the machine. We have a couple connectors inside the machine as well. This one is for the solenoid for our UNIST, and then you can see drawbar output, our door inputs, spindle fan. So everything's easily connectorized. If you have to replace a component, if it fails after a number of years, you just unbolt it, run a new wire for it, and you'll be up and running again. We have our layout sticker here as well. Just trying to keep maintenance as easy as possible, so you don't have to go digging, into page
Googling
47 of the manual. Yeah. If you need a part number for a drive, if you run it as hard as you can and you light your drive on fire, here's your part number. You can just call us up and order a new one. And of course, we still have our parts lists and layouts and electrical schematics in the manual as well if you need them.
This is one of those stupid small things that is so helpful and more companies need to do.
Yeah.
That is, this is why I like Tormach. One of the reasons.
Yep.
And look at our nameplate here. So it says single phase 20 amps at 230.
So 20 amps was on our prototype machines.
Okay.
Every machine does require a 30 amp circuit. If you get the TSC unit or conveyor, those also require a separate outlet and separate circuit.
Of 220?
Yes, 220.
Okay. Sorry, I'm just thinking about my plug situation. Oh, and here's the hose.
Yes.
Here's the hose and
There's
receiver.
our coolant washdown hose, and you can also see the probe receiver there.
Oh yeah, let's talk about the probe.
So on the machine, have it torn apart still right now, but you can see on the backside we have a probe in our tool changer. So that is standard wireless probe and ETS as well. Those run off an optical system.
Like a Renishaw.
Yep, very similar. So yeah, you can use those with our standard built-in probing routines in PathPilot. Or we are also developing a suite of CAM macros that can, probing macros that can be used with CAM.
Did you say the brand? Okay.
Yeah, the probing system is from Pioneer.
So still BT30.
Yes.
Same pull studs as everything else?
Yep, still 45-degree pull stud.
Which, those are the same as the Haas pull studs, right?
I am not sure what pull studs Haas uses for BT30 actually.
Are they the same as like Robo or Speedio or anything?
They're the same as Robo drills. They also use 45-degree pull studs. Speedios use 60-degree pull studs.
So 10K RPM, 4 horse?
10,000 RPM, yep. 4 horsepower continuous, 6 horsepower intermittent. If you're going over 100% through the cycle.
And we saw in the other video that there's the, what do you call it? The gauge on the PathPilot controller.
Yeah, you have your spindle load meter for your spindle built in, as well as for all your axes.
Load meter. Yeah, that's the term I'm looking for. How does the drawbar force compare to this one, on this one to like the MX, or excuse me, the 1100 MX?
Drawbar force is actually the same. We have a spec of 1,000 pounds of drawbar force.
Okay, on both machines?
Yes.
Okay. What about bearings? Are they different on this machine?
Yep. I don't know the exact size of the bearings, but still a 4 bearing configuration, just a larger size. So on the 1100 MX, that was an 80 millimeter diameter cartridge, and on a 70 millimeter cartridge on the 770 MX, and on the 1500 MX, it is a 100 millimeter cartridge. So much more room for bearings.
ABEX 7?
Yes. Okay. They are ABEX 7 rated. Like, as far as the spindle, like that's made by Microlab. The linear rails are made by Highwind. Ball screws, not Highwind, but I don't remember who they are.
I don't have a problem like naming companies, like Pioneer for the probe. I'm a bit hesitant to do so just because people tend to attach onto that. And we don't want to remain beholden to every 1500 MX will have a Microlab spindle. No, we might, if the quality goes down, we might kick them to the curb and get a different supplier, or if their costs go up or whatever. Yeah, people just get possessive about component brands. It's weird. Well, I mean, it's machinists. They do the same thing for controls, so I guess it makes sense. Okay. Everything back together.
So our goal in doing this was to start playing with the ATC. Can you run the ATC with the door open?
Very limited functions with the door open. So we're on the ATC screen right now. You can see that most of these buttons are actually yellow. If I close the door,
Oh, that's smart.
those go to white. So you do still need some functions open for alignment and setup. So you can see here, set TCM19, TC position, or aligning the tool tray to rotate the carousel. So yes, we do have some functionality with the door open. In setup mode specifically, if you change to run mode, this is a beta version, so these will change yellow if you're in run mode or setup mode. But for a full tool change, you do have to have the door closed.
Does that key do anything on the 1100s?
Not in the US. That is
Okay.
CE
I've always wondered
specific.
about that.
Yeah, for 1100s and 770s, that is CE specific for allowing various functionality with the door open, being able to jog at 200 inches a minute versus limited to 78, turning coolant on, turning the spindle on. But on every 1500 MX, we do have certain restrictions in place, both for just our safety standards that we want to apply, but also CE conformity.
Okay. So can we time some tool changes?
Sure. I can set up a quick demo program of just running tool changes.
Okay.
What tool numbers do we have in the ATC?
Can you change from like 800 to 102 to 86, back to 800, then 102, then 86? That way we're doing one tool change that's right next to the other pocket, and then one tool change that's on the exact opposite. Can you still manually change out tools? Like if you just called up a tool, wasn't in the ATC, it would stop and ask you to manually change it?
Yep. And it was doing that earlier when we were running the part. I initially didn't have the engraving tool loaded in the ATC, so it told me take it out before I go to a tool in the ATC. None of that has changed from what we've had in Path Pilot previously.
Oh, and how many tool pockets?
16.
And 12 on the 1100?
Yes, 12 on the 1100 MX, 10 on the 770 MX.
Okay. So more than a mini mill.
So we'll change from tool 102 to tool 800 to tool 86, and then do that again, a third time, fourth,
Okay.
5 times.
I wonder if I can do an on-screen timer in editing. I'm going to do that.
We also have our cycle time counter.
Okay.
So if I'm going to start this first, I should manually change to tool 102 to begin with, though.
It's not the fastest tool changes I've ever seen. It's faster than the 1100. That's definitely faster than the 1100.
Yes.
That's a lot faster, turning the carousel.
Yeah, one thing to keep in mind, too, is that with 16 tools, we have a much larger diameter platter.
Uh-huh.
So the inertia of the entire carousel is much, much
That's
greater.
real, yeah.
Yeah. So for our testing, we loaded up 16 half-inch drill chucks that had 6-inch projection. So if you have a fairly lightly loaded tool tray, we could go faster, but we have to keep in mind we have to set the speed for the worst case scenario.
Yeah. And I don't think that's, like, in terms of quote unquote wasted time, there seems to be a pause. Is that just waiting for the drawbar and everything to settle into place?
Yep. Yeah, so we do have a couple dwells in the cycle. Compared to what we had on the 1100 MXs, those are reduced quite a bit, but we want to make sure we leave enough time for the drawbar to open and that we're clearing off any chips with the air blast nozzle as well.
It's not a speedio, but it's totally reasonable.
Yep.
That's probably good.
I'll let it run through the whole cycle.
Okay, then we can, how many tool changes are in that?
So we started at 102,
It's 15.
14.
Oh, because the first one's not a tool change.
Yep, so 14 tools.
14 tools, where's the, and we're coming up on 2 minutes?
A little over.
I'll get my calculator ready. Where's my calculator? time, 2:33 in 14 tool changes. So we are at 10.92 seconds of tool change.
Yep.
And half of those were worst case scenario.
Right.
I guess half of them were best case scenario too. but-
Yeah, so that's fairly average.
Yeah, that's not bad. That's pretty good. All right, so rough operating with, give it a little bit of margin, like actually real what you would want.
I'd say at least 18 inches for me to get
This
to the
is
side
slightly
of the
larger
machine.
than 18 inches.
Are you at the side of the enclosure or no?
No, I'm a couple.
Well, you go 18 inches and I'll measure to the side.
So 18 inches.
Okay. So we're at 7.5 feet to the side of the mouse pad here.
Okay. What about depth?
So
All right, I'm not going to give the operator any room. No room
Okay.
for the operator, about there.
So this is to the back of the unist, which you
So if
consider
you
that-
don't have a coolant system,
Right, if you don't, it's just under 6 feet. You add in the coolant tank, you're at about 7.5 feet.
okay. How much room do you need back there to maintenance and stuff?
So you really only need the width of the coolant tank. The door of the electrical cabinet, when it swings open, it's within the footprint of the coolant tank. So as long as you're able to stand comfortably, if you're having to do any electrical maintenance, and you're fine there, the coolant tank itself can roll out straight to the side. So
Okay.
you don't need any additional room behind it.
Yeah, and to be fair, you have it pushed up right against another machine.
Yes.
So,
Yeah, and we have had it pushed up right against the wall with 3 inches of room-ish. So just depends on your exact machine placement, really.
cool.
Yep.
Well, do you have anything else cool to show us?
Nothing comes to mind.
All right. Well, thank you for the deep dive tour. I appreciate it. It's been a fun couple days.
Yeah.
All done. Finn.